Hello, PreCalc. February the 1st, can it really be? Here we are watching this video after Wednesday's class, and we are looking at hyperbolas again. I'm assuming we got to start them today, so I'm just going to reinforce that by showing you one more example from Hyperbola land. I think my videos got ahead of the classwork, so that's why I'm just doing a little bit on hyperbolas tonight. It seemed like you were just rolling downhill with circles like cheetahs that fast. But when you hit parabolas, you turned into a herd of turtles. So I was surprised that parabolas took a little while, but you got through them famously. And then ellipses, you were back to cheetah mode. So hopefully hyperbolas will continue in like manner. Here is the standard form for hyperbola. Standard form. So this should be at your fingertips somewhere in your comp book or your notes. There it is. Remember, you can tell a horizontal by a vertical by which term is positive. If you have an x term that's positive, it is a horizontal. If the y term is positive, you have a vertical. Alright, so back here the negative goes to the y, and here the negative goes to the x. So we're looking for the positives. Alright, so with that in mind, I will present the problem. I think you've gotten to it today, so try to go a few steps without me. Turn off the video and give it the old high school try. I like to gather my positive terms first. So when I'm doing that, I see a positive y squared. So I'm going to gather my y's first. So doing that, here's my one y, here's my other one. So I'll gather those, and then my negative ones. 4x squared. And this says negative 8x, but since I already pulled the negative out, I have to call it positive 8x, because that negative will include it. And leave a space, move the number to the other side. Alright. Now we're interested in completing the square, but two things have to take place before we can. We have to deal with this and this. Do you remember what it is? Alright. Depends whether you're a turtle or a hyena tonight. Alright. Hyenas, you got it. Turtles, join us. Take out the 25. We call it factoring. Behind it, how many 25s go into 150? So it's like how many quarters in $1.50? There are 6. Alright. And take out the 4. And we get x squared and a negative 2x. You always can check by multiplying and getting back to what we want. Alright. So continuing, I will now complete the square and adjust the other side. Alright. When I complete the square in here, I take half of that and square it. So I get a plus 9. Here I take half of this and square it, and I get a plus 1. I can't just go in and change the problem by adding a 9 here and a 1 here, so I have to adjust for it on the other side. And I would be tempted, oh so tempted, to add a 9, but this is just a 9 in disguise. It's really a much larger number. It's really a 25 times a 9. So that value, I believe, is 225. So I'm going to have to add 225 over here because I actually added 225 over here. So what did I do here? It looks like a 1. It's masquerading as a 1, but it's really a minus 4. So I have to do whatever happened on this side, I have to do the same thing on that side. So when I subtract 121, add 225, and minus 4, I come up with, ta-da, you can almost tell when you're getting it right because it usually comes up to a nice number. And I say 100 is a nice number. All right, coming back here, I have a 25, and I must complete the square. I added a number to complete the square. What is the perfect square I created? I go from 3 terms to 2 terms squared. So if you multiply y plus 3 times y plus 3, and you do the 4 steps, you will get this. And the minus 4 still sitting there. What's the perfect square here? X minus 1. Alright, and that all equals 100. Alright, we want this to be a 1 because we want to be like in standard form. So can you tell? Well, we'll get to that in a minute. Alright, so let's divide by 100. Okay. Alright, are you with us? How you doing there? Bree, are you with us? How about you, Ryan? How about you, Alex? How about you, Maggie? Are you with me? I hear 4 yeses. Because 25 goes into 100 4 times. I'm reducing 25 over 100. 25 goes into itself. 25 goes into 100. Reducing. This over here reduces to 25. 4 into itself once, into 100 25 times, equals the much desired, long sought after 1. Alright, we are in standard form. Is this horizontal or is it vertical? I hear the chorus across the miles. When y is positive and the negative is the x is behind the negative sign, so we're looking at the positive y, it is vertical. Alright, so the center, Hector and Kyle, you always find what's hooked to the x, opposite sign, what's hooked to the y, opposite sign. That is the center. So we'll go ahead and sketch the center. Center is 1 over and 3 down. Right there is the center. It's not on the hyperbola. In fact, it's in the middle of a very special box. And we come up with the size of the box by doing a sissy chart. We're going to do x is 0, y is 0. That's a y, by the way. Alright, x is 0, y is 0. So, and we always use the cousin of this. So instead of using this, we're going to drop Hector and Kyle. We already got the information we need. So we're done with you, Hector and Kyle. So we're going to discard them for a minute. So notice this is what's left if I drop out Hector and Kyle, and that makes this very simple. I can do it mentally, and I hope you can get to that point as well. So I'm going to zero out x. So this term is gone, so I'm imagining that not there. So I have y squared over 4 equals 1. And I multiply both sides by 4, and I get y squared equals 4. Take the square root, and I get y equals plus or minus 2. Alright. I can do the same thing with the other side. This time this zeroes out. The negative 25 comes over here. The square root of negative 25 is plus or minus 5i because of that negative sign in the radical. Alright, so I am going to start at my center, and this tells me to go 0, x, and I'm going to go, this tells me to go up and down, the y value. So I'm going to go up to here and down to here. So from the center, I'm going to go up 2 and down 2. Then this tells me, ignoring the I, from the center, I'm going to go over 5, about right here. And over 5, 1, 2, 3, 4, 5, about right here. These are the, doesn't look very symmetrical. Let me move these a little closer together so they match more of this side. So put that back in. It's going from bad to worse. I'm becoming a turtle. 1, 2, 3, 4, 5. Alright, starting counting from here. 1, 2, 3, 4, 5. So it'll come in a little bit. It's right under here. Alright, it's supposed to be symmetrical looking, but I have my tick marks not very rhythmic. Alright, this becomes a box, and the box, these are the midpoints, the points that I just gathered from my sissy chart going from the center. These are the midpoints of a box. And I'm going to draw the diagonals of the box. Diagonals go from corner to corner, and it should go through this point too, which it does when I make it larger. So these are the fence posts. They're called asymptotes, and we have to decide whether the parabola, didn't say that, the hyperbola hits this way or this way. Well, we already had that discussion. We decided over here, when y was positive, that it was a vertical. So vertical means it opens up and down. So I'm going to hit this point, and I'm going to obey these asymptotes. So it's very wide. Unlike the parabola, this is bounded. It will never cross these lines. And this one, paper in the way. This one, it's going to go forever like this. Alright, pretty bad graphing job. Hopefully yours is a little more symmetrical looking and hyperbolic looking. Alright. That is my example for today. So put your turtle shells away and put on your running shoes so you can go quickly down the hyperbolic hill. So in other words, work quickly on these. Study this example again, and we'll be on our way tomorrow. Till then, good night.